Today we're going to talk about confidence intervals for two population proportions. Right, so as we're going through this section, in some ways it is going to mirror a lot of different things in our process that we saw in section 7.4 when we were building our confidence intervals. The difference is, instead of just looking at one proportion, we're going to be comparing two different sample support proportions, and we're going to talk about the difference between those two population proportions. Right, so our difference. Even if two population proportions are equal for two populations, the sample proportions drawn from these populations could be different. So confidence intervals are one method for determining whether different sample proportions indicate there are real differences based on the population proportions. So as we're looking at these and as we're going through these problems, our comparison is going to be based on the statistic P1 hat minus P2 hat. And we're going to use that sample statistic to estimate our population difference, which is going to be a P1 minus P2. As we are building our confidence intervals for two proportions, instead of just using a P hat, we're going to be using our P1 hat and P2 hat, and we're going to be estimating our confidence interval for the difference in our proportions. So everywhere we just saw a plain P or P hat before in section 7.4, we're going to see this P1 minus P2 or P1 hat minus P2 hat. If 0 is included in our interval, right, that suggests that our two population proportions might be the same. If 0 is not included in our interval, then the confidence interval tells us how much difference there is between these two different values. So as we're looking through the problems in the next couple of pages, as we're thinking about our interpretations, what we're looking for and what we're checking for is to see whether or not 0 is included in our interval. All right, so on this page, we're going to start with a list of some different questions we want to think about, questions we want to ask ourselves. All right, so the first question is what we just mentioned: is 0 included in our interval? If 0 is included, then we cannot rule out the possibilities that the population proportions are equal. So a lot of these questions that you're going to see, we may have statements at the end that say, well, the populations may be equal to one another. If we do not include 0, and if both values are positive or negative, right, then that means that the comparison between population 1 and population 2, it's going to show us which one is larger. Right? So if it's positive, that's going to mean that population 1 is larger than population 2. If it's negative, that's going to mean that population 1 is less than population 2, based on our difference that we're looking at. Our greatest possible difference is going to be the upper limit of our confidence interval. The smallest possible difference is going to be the lower limit of our confidence interval. And what these are going to tell us is, again, how much our proportions are going to differ. So this table kind of nicely summarizes our different results that we may get in different ways that we're going to interpret our confidence intervals for our two proportions. And so the first thing that we're going to do is we're going to look for, again, and see if 0 is included in our interval. If our interval contains 0, then our population proportions may be equal. Right? If they are both positive, right, then P1 is going to be greater than P2. If both values are negative, then P1 is less than P2. Right? As we're going through these problems, it doesn't really matter which one we choose as population 1 and which one we choose as population 2, because as we're looking at these, the notation doesn't really matter as long as we keep which one we have labeled as each different population separate as we're going through these different questions. All right, so we're going to start with a couple of basic interpretation questions based on our two proportion confidence intervals. And then after we work through a couple and just talk more about our interpretations, we will also work through our process for finding these different intervals. So extracting natural gas through a hydraulic fracturing or fracking is a controversial practice. Residents in 2 states with large natural gas deposits were polled to determine whether they were in favor or oppose fracking. Let P1 represent the proportion of Michigan residents who favor fracking, and P2 represent the proportion of Pennsylvania residents who favor fracking. A 95% confidence interval for the difference is shown, and it's given negative 0.0184 to 0.0117. All right, so we're going to interpret this interval and decide whether or not, based on this interval, we can just that there is a difference between the support in these two states. All right, so we're going to start by listing what we know. All right, so P1 is our proportion of Michigan residents, right, who favor fracking. Right, and we're told that P2 is our proportion of Pennsylvania residents in favor of fracking. We are told our confidence level is 95%, and we are given a confidence interval of negative 0.0184 to 0.117. And what we want to decide, what we want to look for first is 0 included in the interval? Okay. So as we are interpreting confidence intervals for two different populations, right, what we're looking for is 0 included in our interval? Right, now looking at this particular confidence interval, our confidence interval goes from negative 0.0184, or about negative 2%, to 0.117, or positive 11%. So since we have one negative number and one positive number here, right, our confidence interval does include 0. So we're going to, for our interpretation, say the confidence interval includes 0. So we cannot rule out the possibility that the proportion of people in each state favoring fracking is the same. Right. So since our interval includes 0, we cannot rule out the possibility that the proportions are the same. Right. Our second question, does this interval indicate there is a difference in support of fracking? Right. Basically, it's just another way of restating our interpretation. So we're going to say we can conclude that there is no significant difference in the proportion of those who favor fracking in both states. Again, this is also because 0 is included in the interval. So our first sentence is just a kind of blanket interpretation of our confidence interval. And then the second question asks specifically, is there a difference? And we cannot conclude that there is a difference because 0 is inside our interval. In our interpretation, it's also worth noting. So we're going to talk a little bit about these actual two different values that we have here. So we're going to have a couple of statements down here at the bottom. And we're going to start with stating the positive 0.117 means that it is not implausible for the percentage of Michigan residents to be 11.7% above Pennsylvania residents. So the positive values mean that P1 is greater than P2. And if we go back up to the beginning, P1 we said was Michigan. So if we're positive P1 is larger than P2, and more specifically, 11.7% above P2. Right? We also have a negative value here. Right? So the negative 0.0184 means that it is not implausible for the percentage of Michigan residents to be 1.84% below Pennsylvania residents. Right? And this is because it is negative. Right? So if it is negative, that means that P1 is less than P2. Right? So Michigan would be 1.84% below Pennsylvania. All right, so we'll go through one more question talking about our interpretation of these differences. So back in chapter 1, this example actually relates to one that we talked about when we were talking about our controlled experiments. So in chapter 1, we learned about a study of 2 treatments for Crohn's disease, Inflix or Azeth. 169 patients received Inflix and 75 were in remission at the end of the study. 170 received Azeth and 51 were in remission at the end of the study. Let P1 represent the patients who would be in remission taking Inflix. P2 represent the patients who would be in remission taking Azeth. A 95% confidence interval is found, and it is 0.04 to 0.25. All right. So to start with, our P1, we're going to say our proportion of Inflix patients in remission. Right, P2 is going to be our proportion of Azeth patients in remission. Right, our confidence level is 95%. Our confidence interval is 0.04 to 0.25. All right, so the first thing we want to look at, right, is we want to know, is 0 included in the interval? Right? And to determine whether or not 0 is included in our interval, again, we're looking to see if we have one positive and one negative in our interval. That's clearly not the case in this one. Right? So our interval is not going to include 0. Right? So then that brings on a second question. If not, right, are both values positive or negative? Right? And what does that mean? All right, so looking at this specific example, right, we're going to start for our interpretation. We're going to say the confidence interval does not include 0. which tells us we are confident one treatment is significantly different from the other. Looking at this then, 0 is not included in our interval, and both of our values are positive. So we want to determine what that means. So we're going to say the values are all positive. So the proportion is greater for population 1. Right? So if all of our values are positive, the proportion is greater for population 1. If all of our values are negative, the proportion is going to be less. But in this case, it is greater. Right? So P1 is greater than P2. Right, we can then use this to answer the question, which treatment is better? Well, if P1 is greater than P2, right, we can conclude that influx, right, which was administered in population 1, is the better treatment because P1 is greater than P2. And then using the numbers given to us in our confidence interval, we can say the difference is between 4% and 25%. So again, as we're thinking about our interpretations, if we're comparing two different populations, the first thing we want to look at is 0 included in our interval, right? If it is, then our proportions may be the same. If 0 is not included in our interval, right, then are they both positive or are they both negative? Is P1 greater than P2 if they're both positive, or is P1 less than P2 if they're both negative?